All right, in 9.1, we're going to start solving quadratics by graphing. And it's been a while since you've graphed equations, so we're going to revisit some terms that you may remember, you may not. So when I talk about graphing and we're looking for solutions, we are looking for x-intercepts, we are looking for roots, we are looking for zeros. They all are the same exact thing. Where is it crossing the x-axis? That is what we're looking for. So when we're looking at solutions, there are some other things I want to bring up. So let's stop for a second. If I have a linear equation like this, and then let's say I have a quadratic like this, I can look at the equation and know how many solutions it's going to be. Because a linear, the highest degree right here is a 1. This one has a degree of 2. So what I want you to remember is that terminology. From the equation, you can tell the degree equals how many solutions. How many x-intercepts, how many roots, how many zeros. Now, okay, that's fine and good, but what about when you have a quadratic, let's just draw a parabola. When I look at the graph, I know where it crosses the x-axis. This one has nice, easy 2 x-intercepts. I can see that, I can find them. But what if it looks like this? What if it sits on the axis and looks like it only has one solution? Well, it actually has 2. We call this a double root. It's a double, and it kind of like bounces off the axis. But then what if it doesn't touch it at all? Like it's way up here and never ever crosses it. Well, if that's the case, it has solutions. They are just not real. They are imaginary. Imaginary solutions, and that happens. So let's practice doing this and using what we know to find the solutions of these quadratics. So let's look at number 1. All right, so number 1, we're going to graph this and state the solution, 0, root, x-intercept, however you want to call it. So let's look at this. Our vertex, remember, h and k, vertex is going to be a positive 3 and a negative 1. So positive 3, negative 1, going to come right here. And then I'm going to look at the slope, if you will. Notice the a value is just a 1, so it's going to follow just like the parent function did. So I'm going to go up over 1, up 1 on both sides. Over 2, if I square it, I go up 4. 1, 2, 3, 4. And there's my quadratic. No big deal. Now I can see from the graph where it is crossing the x-axis. So I can see these points very clearly. So I'm going to write them as coordinate pairs. So it's going to be a 2, 0, and then at 4, 0. So make sure you're writing them as coordinate pairs. There's my solutions. Let's look at number 2. Okay, where's my vertex? Okay, my vertex is going to be at negative 6, negative 9. Remember to change the sign of h. So if I go over negative 6, this is a 10 by 10 grid, so it's a little tinier. And go down negative 9, that gets me right here. Now look at my slope, it's a 1a, so it's going to follow the parent function. Just go up 1, over 1, up over 2, up 4. And there we go. Now, I need to know where it's going to cross the x-axis, so I need to keep going. So I'm going to go over 3. Well, 3 squared gets me to 9. That puts me way up here, and then way over here. All right, so if I connect my dots, I can see my parabola, my quadratic, very nicely, neatly, and I can see my solution. So I can see that it's at negative 3, 0, and at negative 9, 0. Alrighty. Let's look at number 3. This one's going to be opening down. I hope you see that. My vertex is going to be, what, negative 4, 0. 1, 2, 3, 4. And it's opening down. Remember the negative? It means it's opening down. But it is just the regular slope. So I'm going to go down 1, over 2, down 4. And I can see where it crosses the x-axis, and that's the objective, so I'm good. Now, so I have my solution. It's at negative 4, 0, but I have to account for both solutions, right? So I need to write the word double with it. make sure you write the word double if it is a double root. So I know that you know that there are two solutions there. Let's look at number 4. Where's our vertex? Okay, our vertex is going to be at 5, 1. So let's find 5, 1. 1, 2, 3, 4, 5. Oop. And 1 is up 1. Now, it's opening up because it's a positive A, but it's a slope of 2. So if I go over 1, I'm not going to go up 1, I'm going to go up 2. So it's going to be skinnier. Over 2, when I usually go up 4, I'm going to go up 8. All right, so I'm just going to reflect this on this side. And there it is. Okay, now notice it's not crossing the x-axis at all. So what the heck do I do? Well, I just say there's no real solutions. But your graph has to support that, okay? No real solutions. Now let's talk about how we do this with our calculators. Now, when you go to your calculator, you're going to have it graph the equation, and it's going to walk you through, I'm going to walk you through how to find those zeros on your calculator. All right, so I'm going to graph this one, and then I'll show you a video in a moment of how it's going to work. Okay, so when we graph this in our calculators, obviously you're going to go to your y equals and put in the equation. So this is the equation that I did on number 1. Put that equation in there, and if I go to the graph button, you will see my graph. Now, it's going to look a little different on your calculators, but you see the graph. Now, I want to show you how to find the places exactly where it's crossing the x-axis, because you can see that it's between 1 and 3. It's not very clear. My screen does tell me the zeros, but your screen will not do that. So how does it do that? Well, if I hit second and trace, the second option is 0. So I'm going to hit 0. And notice it asks me, where's the left bound? Okay, notice the little blue, there's a clicker. And if I hit the left arrow, it's moving left. Now, the 0 is where it's crossing the x-axis. So I'm going to go to the left of it, just left of it somewhere. I'm going to hit enter, and notice it drew a boundary. Then it says, where's the right boundary? Well, the right side of that first 0, I'm going to go down until I'm on the right of it. All right, and then I hit enter, and it found that exact point. So you're basically narrowing down where it could be. So there's the first 0, negative 0.618 or 0.62. All right, so then if I want to find the other 0 on the right side of the equation, I'm going to do the same process. So second, trace, gives me to calculate, and I hit number 2. Second, trace, takes me to 0. So if I go to the left of that first one right there, it feels weird because it's below it, but think domain. It's just to the left of it, so hit enter. Go to the right, hit enter, and then it's going to find that 0. So notice at the bottom it says x equals 1.618 or 1.62. Now on your school calculators, it's going to say guess, and you hit enter until it gives you the exact coordinate pair. So you would have x equals 1.682, comma 0. So make sure you write these as zeros. So on the calculator, I found that my zeros were a negative 0.62, so we're going to round to the hundredths, and then a positive 0.62. All right, hopefully that calculator thing helped you find that out. So I wrote down here for you the keystrokes that I did. The second calc 2 is 0, and then you're going to follow those prompts. Remember what I mentioned. It's going to ask you, find the left boundary, and you go to the left of the first 0, find the right of this first 0, and then you hit enter, don't hit guess, hit enter, and it'll find that value for you. And then you have to repeat the process to find the left boundary of the other 0, do like that. All right, so now on these other ones, I'm not going to make a video of me doing it on the calculator. I want you to practice on your calculator and see if you get what I got. So number 2, I got negative 1.240 and 3.240. All right. On number 3, I got negative 2, 0, and -1, 0. And then negative on number 4, I got a double root at 2, 0. Now, a couple things. When you run into a double root, what's going to happen on your calculator, it's going to be like, it's going to say x equals 1.99999. So if it's a double root, it's never going to be exactly right, but you can see from the image, it's really at 2. So we're going to make that a 2. So double roots do this weird decimal thing, so we can adjust. We're smarter than the calculators. Now, a couple things that might be helpful on your calculator. If you need to zoom in to see closer, what you can do is click on zoom, number 2, and then you have to hit enter or it won't actually zoom in. All right, you do that to get a closer look. All right, let's say you did that on one problem, but then you needed to go back to the regular screen. So then you would hit zoom 6. If you hit zoom 6, you don't have to hit enter, and it returns to the normal 10 by 10 screen. All right, so there's some calculator work for you. I hope that the videos help, and we'll discuss it also when we get to class.